Well, hello to everyone. For those who don't know me, my name is Mark Gillette. And before I take a few minutes to kind of introduce myself, I would like to give a special shout out to some of my guests that are watching from all around the country. I invited libraries around the country, and so there may be staff members and patrons that are attending at Prince George's County Memorial Library in Maryland. Welcome. Wilhelmina Public Library in Oregon. Welcome. And I know that Sarah is attending, so thank you. Cooper Siegel Community Library in Pennsylvania. Houghton City Public Library in Texas. Southworth Library in New York. Russell County Public Library in Virginia. The S.W. Smith Memorial Public Library in Pennsylvania, the King County Library System in Washington State, Glassboro Public Library in New Jersey, welcome. City of Boulder in Colorado, welcome. The Harlem Public Library, welcome, in New York, New York. The Technology Engagement Center in the Rutherford City Library System in Tennessee, welcome. Winford Library in Illinois, the Laurel Public Library in Delaware, and I see that Kristen is attending, so welcome to you as well. The Osceola County Public Library in Kissimmee, Florida. Pipkin County Library in Aspen, Colorado. Grand Forks Public Library in North Dakota. The Solano County Library in California. The Cudahy Family Library in Wisconsin, Lake Dallas Public Library in Texas, the Harris County Public Library in Texas, the Florissant Public Library in Colorado, the Gayago Public Library in Ohio, and last but not least, the Maitland Public Library in Florida. So again, welcome so much. My name is Mark Gillette, and I am a sociology professor at Valencia College in Orlando. I am a native of Central Florida, born and raised here, and I live in a very quickly growing city called Davenport, just south of Orlando and just about 15 minutes from the Walt Disney World Resort. So I would like to thank you for coming and spending part of your day today with me. I am a NASA Solar System Ambassador. The NASA JPL Solar System Ambassador Program is a joint venture between NASA and JPL. And as an ambassador, I go out into the community, and now with the coronavirus, I do online events promoting NASA missions and programs, kind of informing the public of what's happening. The Solar System Ambassador Program has been around quite a number of years, and it's, I think, a very awesome program that they offer to the public. To me, it's kind of as an ambassador, it's kind of like, the way that I like to describe it is, it's kind of a fancy title for being an unpaid volunteer. But I really, really enjoy it. And you might ask yourself, well, what is a sociology professor doing talking about NASA and cosmology and astronomy? Well, it's very simple. I'm extremely passionate about it. I've always had a passion for astronomy and the space program. And it's only been in the last several years that I've really kind of started digging in and learning a whole bunch more about it and getting into it. So I'd like to share some of the knowledge that I have learned with you. You're going to see if you are on if you're on a laptop or a desktop, maybe even on a cell phone, a portable device, there should be a chat box. And at any time, if you have any questions, feel free to type those questions in the chat box. And what I'm going to try to do is I'm going to try to look over to my iPad here periodically, look for the questions and address them as they come through. I apologize if I look over your question, and at the end there will be a time for questions and answers. So if I didn't answer your question, make sure to bring it up again. If you see me doing this, all I'm doing is I am looking over at my iPad, looking at the chat feature. so that I can see if there are any questions or anything that are coming through. If you have any problems with audio or the displays, please let me know in the chat box, and I will see everything that I can do to fix it. The last time I did one of these YouTube live events, I did have some connection issues that occurred a couple times, so I do apologize if that happens again. And what I'm going to do is I'm just going to sit here, and hopefully those problems will resolve quickly and just keep right on going. I want to warn you that even though I had planned this to be an hour long, I have a funny feeling I'm going to go over an hour, and that's because of my passion. Once I get started talking about this stuff, you can't really shut me up. So if you need to leave, I will not be offended in any way, but you can always come back and watch the rest of it, because this live event will be archived on my YouTube channel probably in about 24 hours within it actually happening. So I also want to mention that I will be having another YouTube live event on Tuesday, May 19th from 7 to 8 p.m. Eastern Time. It's going to be similar to this, but I'm going to add in some new content. So even though you've seen this, you might want to come back if you're available. I'm also going to have another one on Thursday, June 25th from 3 to 4 p.m. Eastern Time. So please make sure that you mark your calendar for that. In addition, please don't forget to subscribe to my YouTube channel. Don't forget to click the little bell so that you know when I upload new content. And what I'd like to do is, if you all like what you're seeing, I would like to put together some more presentations for all of you. And I'd like to know what topics you'd like to hear me present about. So you can type those in the chat box at any time, or even after the end, after you've heard what I'm going to talk about today. All right, so I think I have covered what's on my sheet here. Here's our brief agenda for today. We're going to talk a little bit about the past of NASA, specifically talking about the Apollo program and the Space Shuttle program. We're going to then go on and talk about, well, what's happening now? And I'm going to focus on just kind of like four things. Talk about the ISS. We're going to talk about some satellites, landers, and rovers. We're going to talk about the Commercial Crew program, a very exciting program, and something very special coming up next month when it comes to the Commercial Crew program. I want to talk quickly about CubeSats, and then we're going to wrap it up with both talking about the two major missions that are coming up with NASA, the James Webb Space Telescope and the SLS and Orion program, now called Artemis, and then talking about or answering your questions with Q&A. I'm going to be showing you some pictures, and this is the first one I'm showing you here. Many of the pictures I'm showing you are pictures that I've taken, and I also want to give a shout out to one of my friends, Leonard. Leonard, a couple years ago, helped me to really get into astrophotography. And so I purchased a telescope, and I go outside and I open up the lens and I start clicking away. And if you aren't familiar with doing astrophotography, it's all about collecting light. And so this picture that you're looking at here on the right-hand side of the screen is not just one picture. It's actually 60 30-second exposure pictures all stacked together with computer software. And the more pictures you take and the longer your shutter is open, the more light that you get out. So this is an edge-on galaxy, so you can see that we're seeing the edge of it. And this is NGC 4565, and this is called the Needle Galaxy. This is between 30 and 50 million light years from Earth. Okay, let me repeat that. Between 30 and 50 million light years from Earth. I didn't say 30 to 50 million miles from Earth. There's a big difference between light years and miles. So what is a light year? A light year, it's a measure of distance, not time. It's the distance that light travels in 1 year. So light roughly travels at about 186,000 miles in 1 second. And to me, that's pretty incredible, because that's really, really fast. So how far can light travel in 1 year? Well, about 5.8 trillion miles. So when you go outside at night and you see the stars, you're not actually seeing the stars as they are right now. You're seeing stars as they appeared based on how far away that they are. So you're kind of looking at history when you're looking at stars. I have a short little video that I'd like to show you about light years. All right, so that gives you some additional information about what a light year is. Let's kind of put this in perspective then. How close are the closest stars? Alpha Centauri A and B, which are a binary star system, and I'll come back to that in a moment, they're about 4.37 light years from Earth. In miles, that's about 24 trillion miles. So you can see, and those are the closest stars to us. So when we talk about things out in the universe and out in our galaxy, talking about miles just simply doesn't work. So what scientists do is they talk about light years instead. Over on the right hand side, this is a picture I took of Sirius. Sirius is the brightest star in our night sky, and it is a binary star system. And so what is a binary star system? A binary star system is a system that has two stars orbiting their common center. What may not be known about among a lot of people when it comes to stars is that actually more than 50% of all stars have two or more stars that are gravitationally linked to one another. Okay, so when you think about our star, we call our star the sun. There's only one. All right, but that's kind of the oddball, or within the minority, because as I said a moment ago, most stars have two or more stars within a system that are orbiting their common center. So that's pretty interesting. So if we had more what's the normal, when we go outside it during the day, we would not see one star or sun, we would actually see two. All right. A little bit more about astronomy before we get into NASA. The universe is a really big place. So these are two pictures that I've taken, again with my friend's help, Leonard. And so on the left-hand side, we have the Andromeda Galaxy. The Andromeda Galaxy is the nearest large galaxy, part of what we call the local group, to our own galaxy, the Milky Way galaxy. The Andromeda Galaxy is about 2.5 million light years from Earth. Okay, so we're talking trillions upon trillions upon trillions upon trillions of miles from our planet, the Earth. These are two satellite galaxies of the Andromeda Galaxy that you see here and that you see here. The picture on the right-hand side is a picture that I took of the next largest large galaxy to our own Milky Way, and that's called the Triangulum Galaxy, M31. About 2.7 million light years from Earth. All right. So if you are interested in astrophotography, it's all about getting a good quality telescope, having a good quality camera, and having a tremendous amount of patience when it comes to gathering all of the data that you need, all of the pictures, the images, and the light, and then software to stack all of this together to get things what you're looking at here. Now, my pictures are nothing like the quality of NASA's pictures, but I will say that I'm very proud of those pictures that you're looking at here because I took them, so I get very excited about them. All right, 2 more pictures before NASA, and the universe has a lot of really cool stuff. On the left-hand side, we have the Flame and Horsehead Nebula. A nebula is basically an area that contains dust and gases, and so you can see the Horsehead and Flame Nebula in the Orion constellation. Over on the right-hand side, you see a picture of our star, the Sun. This little area that you see right here, this is called a solar prominence. This extends between 10 to 12,000 miles from the surface of the Sun. Okay? To give you an idea of how big our Sun is, the Sun makes up about 98 to 99% of all of the mass in our entire solar system. If we took the Earth and we took it up right next to the Sun, we could actually put the Earth has a diameter of about 8,000 miles. We could very easily put the Earth in that little area right there. Okay? Quite amazing how big the Sun is. All right, let's talk about NASA. NASA was established in 1958. There have been several programs and missions that NASA has run since 1958, and I'm going to focus on just a few of them. The first one I'd like to spend a couple minutes talking about is the Apollo program. And last year in 2019, we celebrated the 50th anniversary of Apollo 11, the first landing of humans on the moon, July 20th, 1969. Okay? There were 2 major programs that led up to the Apollo program. We had the Mercury program, which was the program that was all about getting American astronauts into low Earth space. And the second program was the Gemini program. And that program was testing out all of the systems and the hardware needed, which will lead to the Apollo program, the landing of humans on the moon. So I have a short little video for you to take a look at about the Apollo program.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
T-minus 60 seconds and counting. We are go for Apollo 7 at this time.
And from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good earth.
We have ignition sequence start. Engines on. 5, 4, 3, 2.
Listen, Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind. We leave as we came, and God willing, as we shall return, with peace and hope for all mankind. Right away, Houston.
From 1969 to 1972, we had, a total of 6 moon landings. 12 humans walked on the surface of the moon. We have elevated the human condition. We have improved human lives. We have raised the standard of living for every person on Earth because of space exploration.
Now, I don't know about you, but that gets me very excited. When I think about all of the work, all of the imagination, all of the courage that it took to put human beings on the moon, that's very, very, very exciting to me. as a sociology professor, I often share with my students that we seem to spend so much time judging one another and hating one another and trying to make ourselves look better than other people. And so what we do is we really fight among ourselves and stop our progress. But to me, it's amazing what we can do when we all come together and fight for a bigger cause. And the Apollo program, I think, is one of the best, if not the best examples that I can think of. As the video mentioned, there were 6 moon landings. The first one was on July 20th, 1969, of course, Apollo 11. The first man on the moon was Neil Armstrong, followed by Buzz Aldrin. Like I said, there were 6 landings. The last one was Apollo 17. Apollo 17, the last man left the moon, Gene Cernan, on December 14th, 1972. All right. Apollo 13, of course, was a very famous Apollo mission. Things did not go right. If you have not seen the Apollo 13 movie with Tom Hanks, it came out in 1995, I highly, highly recommend it. But what an awesome program. The program actually was supposed to have 3 additional launches, Apollo 18, 19, and 20. Unfortunately, because the public lost interest and Congress cut NASA's funding, they canceled those 3 programs. Now, to me, I don't know how it is possible that the public could lose focus or lose interest in human beings going to the moon. But apparently that's what happened. On the left-hand side, you see the rocket that was used in the Apollo program called the Saturn V. It was called the Saturn V because of the 5 main engines. On the right-hand side, you see the command module. The command module, when launched, was right there. So that's where the astronauts would be on the rocket. They would launch, and when they come back, it would only be the command module. So this is lifting off from the Kennedy Space Center in Florida, and this is landing in the Pacific Ocean. If you happen to ever get to the Kennedy Space Center over the visitor complex over east of Orlando in Titusville, you can see one of the actual command modules used in the Apollo program. It was from Apollo 14. Okay. This is a neat little graphic that will show you in kind of like real time. If you look down at the bottom of your right-hand screen, you can see the date and the time that they landed. You can also see the patches. Every NASA mission has a patch that's created, so you can see the patches that will appear on the right-hand side of your screen. On the left-hand side, you can see the actual Apollo landing information. Again, you can see how it's going to go. It's going to skip 13. All right, and again, because Apollo 13 never made it to the moon. So what a wonderful program. It's a shame that it only lasted from 1969 to 1972. It's a shame that there were only 6 landings on the moon. But there's good news. There's good news. We are returning to the moon. And that return to the moon is currently scheduled for 2024, only 4 years away. And I'll be talking about that program called the Artemis program near the end of today's presentation. So please stay with me so that you can hear about this exciting program that's coming up. All right, so there you have it. All right, so the next major program by NASA was the Space Shuttle program. The Space Shuttle program was from 1981 to the year 2011. On the left-hand side of your screen, you see one of the space shuttles being launched from the Kennedy Space Center. And on the right-hand side, you see one of the space shuttles landing at the Kennedy Space Center. The space shuttle was much like a plane because it looks like a plane and has many of the same features, but it actually was a rocket because it was launched like a rocket with solid rocket boosters on each side, and this is the main fuel tank. But when it returned, it landed like a plane, but it didn't have any engines. So the astronauts had to get it right. They had to get it right the first time. because there were no do-overs when you're a glider. So I want to show you just a little bit of this launch video of a space shuttle from Kennedy Space Center. And I'm going to advance this a little bit.
And the handoff to Atlantis' onboard computers. Atlantis now in control of the countdown.
So this is Space Shuttle Atlantis, one of the 5. There were 4 other
Firing
shuttles.
chain is armed. Sound suppression water system activated. T-minus 10, 9, 8, 7, 6, 5, 3, 2, 1, 0, and liftoff of Space Shuttle Atlantis on a mission to build, resupply, and to do research on the International Space Station.
Houston now controlling. Atlantis begins its penultimate journey to shore up the International Space Station. Atlantis now in the proper alignment for its 8.5-minute ride to orbit. 4.5 million pounds of hardware and humans taking aim on the International Outpost. 30 seconds into the flight, Atlantis.
There is absolutely nothing like seeing an actual launch up close. And if you ever get the opportunity to see a launch up close, be it at Cape Canaveral or Kennedy Space Center or one of the other places that spacecrafts are launched, I highly recommend it. I'm so fortunate that I have a friend of mine that works at the Kennedy Space Center, Leslie. I think she may be watching, so hi, Leslie. And she has invited myself and a couple other people out to see a couple launches at Kennedy Space Center in Cape Canaveral. They were of, let's see, the Falcon 9 SpaceX rocket, and I believe one was United Launch Alliance, both day and night. Nothing like it. Absolutely just one of the most incredible things you can ever watch. If you'd like to see a couple of the launches that I had the opportunity to see, spend some time on my YouTube channel when you get a second. I actually recorded the launches from roughly about 3 miles from the pad, and what a wonderful experience that was. So as I was mentioning earlier, there were 5 space shuttles: Columbia, Challenger, Discovery, Atlantis, and Endeavour. So Columbia was the first space shuttle launched on April 12, 1981. And the last one to land was Atlantis. Atlantis landed on July 21st, 2011 at the Kennedy Space Center. There were 135 total space shuttle missions. When the space shuttle was launched, it was into low Earth orbit, which basically means they would orbit the Earth at roughly about 250 miles, so not very far away. They would be traveling at about 17,500 miles an hour. So they were moving really fast. It takes about 90 minutes to orbit the Earth when you're going that fast. All right. Now, Columbia, unfortunately, there was an accident, and Columbia broke apart during landing, re-entry into the atmosphere on February the 1st, 2003. So we lost 7 American astronauts, actually 7 astronauts. The other space shuttle that we lost was Challenger. Challenger exploded about 73 seconds after launch on January 28th, 1986. And the problem there was they found that there was a problem with one of the O-rings in one of these solid rocket boosters right here. There was an O-ring problem, which caused the whole shuttle and everything to explode. We also lost 7 astronauts in that as well. Okay. If you would like to actually see the actual space shuttles in retirement, if you go to the Kennedy Space Center, you can see the Atlantis on display. And if you haven't seen it, I highly recommend it. They did just an absolutely wonderful, awesome job of putting that wonderful piece of machinery on display. So I recommend that. The Endeavour Space Shuttle is at the California Science Center in Los Angeles. When they finally get everything done, they're going to actually stand the Endeavour up vertically, and they're going to have it attached to the solid rocket boosters and to the fuel tank, fake ones, to make it look like it's getting ready to launch. The third shuttle that's left is the Discovery, and it's currently in Virginia near the Washington Dulles Airport as part of the Smithsonian Institute. So those are the locations of the three shuttles in retirement. Okay, so now let's move on and take a look at, well, what's currently happening at NASA. A whole bunch. The very first time that I saw this, I was amazed. I knew NASA was involved with a lot of different projects and missions, but I had no idea that it was this many. So this is a very quick glimpse at both current and planned missions. So just to kind of point out just a few here. Here we have the Earth, and we have all of this research that's going on, scientific research based on these satellites that are orbiting the Earth. We have the Moon. We have the Artemis program that's coming up. I'll talk more about that later. Here we have another galaxy in the background. We have the Hubble Space Telescope. I'll be talking about that in a moment. The Spitzer Space Telescope retired within the last, I believe it's 6 to 8 weeks ago. The James Webb Space Telescope, the next big telescope coming online hopefully next year. I'll be talking about that a little bit later. Here we have our star, the Sun, with some of the missions that are planned or currently happening. Right now, the most popular one is probably the Parker Solar Probe. All right, I'll be showing you what's called NASA Eyes later in this presentation, and you can actually take a look at where this probe is right now, where it's been and where it's going. Incredible software, NASA Eyes. I'll be showing you a little bit later. Here we have Jupiter, and we have Juno, a mission that ended some time ago. We have the Europa Clipper, which is an upcoming mission looking for life on one of the moons of Jupiter. That's a question that often comes up in my presentation. Is there life out there? Don't know. My guess is probably yes. Voyager 1 and Voyager 2. I'll be talking a little bit about those in a moment. And then we have Mars here. Lots of things happening in Mars. We have InSight. We have Curiosity. We have Mars 2020, Perseverance. So just a kind of a big overview of all of the things that NASA is currently involved in or will be shortly. It's mind-boggling. Let's talk about the International Space Station, the ISS. So the ISS is a collaboration of space agencies of countries around the world that came together in the 1990s and continuing on into 2000s to build this marvelous facility, scientific facility, that's roughly about 250 miles above the Earth, orbiting at 17,500 miles per hour. So it officially became operational in November of 2000. So it's now been operational just about 20 years. In other words, there have been humans, astronauts, cosmonauts, that have been inhabiting the International Space Station for about 20 continuous years. Expeditions, as they are called, to the International Space Station are generally about 6 months. Some astronauts will stay shorter durations, some will stay longer durations, but generally each expedition is roughly around 6 months. They are currently on expedition number 63. There is currently 1 American and 2 Russians aboard the International Space Station right now. That's going to be changing in about a month, where there will be 2 more American astronauts joining them, and I'll be talking about that with the Commercial Crew Program in just a moment. All right, so something really cool about the International Space Station. Regardless of where you live, if you are interested, you can sign up for alerts. where you will get an alert or an email from NASA telling you when you can see the International Space Station from your home or anywhere else in the world. And so what you do is you simply go to this website, spotthestation.nasa.gov, and you will put in your sign up right here. You will put in your email address and you will put in your zip code or find the city nearest to you, and then you will receive an email again when it's visible in your area. So this is what one of the emails will look like. It will tell you the date and the time of when it becomes visible. It will be visible for, in this case, 6 minutes. It will tell you exactly where you need to look in the sky. So you need to know where your north and your east and your south and your west are located, wherever you're going to be looking at the International Space Station. You need to know your degrees, all right, from 0 to 90. And if you can figure that all out, and it's very easy to do so, you just simply look on this date at this time in this direction, and you will see, this is a picture I took of the International Space Station with, I think it was with my iPhone, passing above where I live. Now, it is just a little dot. I can assure you that when you look up, you will not be seeing this. Okay, you will not see this. You will see this, a little tiny dot. And so you might think, well, gee, that's not very exciting. It's not very exciting to stand there and watch a little white dot go across the sky just like this for 5, 6, 7 minutes. To me it is. Why? Because I think that, wow, here you have this station that's about the size of a football field with generally 3 or more human beings, scientists on it doing science. 250 miles above us, going 17,500 miles an hour. It may be a little dot, but it's a pretty incredible little dot. So spotthestation.nasa.gov. That's how you sign up for it. Let's talk about satellites. Voyager 1 and Voyager 2. I talked about them a little earlier. Both Voyager 1 and Voyager 2 were launched from Cape Canaveral back in 1977. The major goal of both of these satellites was to explore the outer planets, but they ended up lasting a lot longer than they thought that they would, so they decided to continue the mission, JPL that is. Both of these were built by JPL, both are currently being operated by JPL. They decided to continue the missions, and so both Voyager 1 and Voyager 2 are now in what's called interstellar space, which is between the stars, leaving our solar system. They are the furthest man-made objects away from the Earth. All right. Very interesting. When JPL wants to communicate with Voyager 1 or Voyager 2, they use what's called the Deep Space Network. There are 3 very large radio telescopes, one located in California, one located in Spain, one located in Australia, that they use to communicate with them. It takes roughly about 17 hours to get the communication from Earth to Voyager 1 and Voyager 2. That's how far away that they are. 17 hours. And then it takes 17 hours to do a downlink from that information coming from Voyager 1 or Voyager 2 coming back to NASA here on Earth. That goes to show you how far away that they are. All right? Pretty incredible. Over on the right-hand side, we have what's called the Hubble Space Telescope. I would say probably NASA is extremely well known for the Hubble Space Telescope. It was launched in 1990 aboard Space Shuttle Discovery. It has now been operating for 30 years. It's about the size of a school bus. It orbits the Earth at about 350 miles above the Earth, going also at about 17,500 miles per hour. Many of the pictures that you will see that come from NASA have come from the Hubble Space Telescope. It's an incredible observatory in the sky. Why do you want an observatory in the sky as compared to, let's say, doing observing here on Earth? Well, we have something called the atmosphere. And when we're on Earth and we're trying to take pictures of DSOs or deep space objects here on Earth, we have to deal with the atmosphere. And the atmosphere really distorts our ability to see clearly. So the Hubble Space Telescope gets above the atmosphere and gets a much clearer view of what's out there. Galaxies, stars, nebula, so on and so forth. So some fabulous pictures have come from Hubble. Okay, here perhaps is the most well-known picture that comes from Hubble, and it's called the Hubble Ultra Deep Field. Basically what they did, what the scientists did, was they chose what they thought was a pretty boring section of the sky. They pointed Hubble's cameras in that boring section of the sky, collected many hours of data, put it all together, and here's what they found in the boring sky. About 10,000 galaxies. Okay, not stars. Everything that you see in here, with the exception, I believe, of this right here, which is a star within our own Milky Way galaxy, everything that you see here is a galaxy. Galaxies are made up of hundreds and billions and trillions of stars, all gravitationally linked to one another. Wow. One little tiny unobscure section of the sky. So we can assume, based on what Hubble was able to show us, that there are not 10,000 galaxies in our universe, but there are probably billions upon billions upon billions of galaxies in our known universe. I love this. This is all about intellectual curiosity. You know, what's going on out there? Where are we from? Where are we going? These are the big questions in life. And when I go outside at night and I look up and I see the stars, or I look in the telescope and I see a galaxy, I think, wow, what an incredible universe that we live in. Hubble. Landers and rovers. So landers and rovers. So currently on the right-hand side, you see the Mars Curiosity rover. The Mars Curiosity rover landed on Mars in August of 2012. Many of the landers and rovers that are sent to Mars are generally, the missions are generally very, very short. They may be a few days, a few weeks, a month or so, and then they are expected to end. And the reason that they're expected to end is because there are pretty hostile conditions on the planet Mars. I believe that Mars only has roughly about 34% of the atmosphere that we have here on Earth. Don't quote me on that. So they get a lot of radiation from the sun, for example, and that can cause a lot of damage to things like landers and rovers. In addition to that, they have dust storms, and the dust storms will pick up the soil and will put it on top of the solar panels, like for example on the InSight lander on the left-hand side of the screen. And when too much of this dust builds up, then the batteries are unable to recharge because not enough sun is getting through to the solar panel. So, but in many cases, these programs end up lasting much longer than they anticipate them to, and that's the case with the Mars Curiosity rover. It's been going since August of 2012. Curiosity has gone about 14 miles, has traveled about 14 miles on the red planet. 14 miles to you and me may not be that much, but when you think about all the technology that it took, all of the brain power that it took to put this thing together, to land it on Mars, so many things that had been landed on Mars didn't actually land, they crashed, to land it successfully and to be able to control it from Earth, that's incredible. Mars is what, normally about 34 million miles away from us, give or take, several million miles based on where the Earth is in relationship to Mars, but we're talking millions of miles, and that's pretty incredible, 14 miles. On the left-hand side, we have the Mars InSight lander. This is the most recent NASA mission to Mars. It landed on Mars in November of 2018. It's a lander. What does that mean? That means that you notice it doesn't have any wheels like the rover. It lands and it stays put. It does not move anywhere. Okay, so they want to make sure they land it in the spot that they want to land it in, because if they land it somewhere else, there's nothing that can be done to move it. But right here, you can see that this is a drill, and the ultimate goal is to drill 16 feet down into the Martian surface. And one of the major goals of this project is to take that soil, do some testing, scientific testing and instruments on the Mars InSight lander to see if there are any signs of either current or past life. Okay, it's probably not going to be the little green men with the antennas that we always think of. It's probably going to be some type of microbial life. To me, it doesn't really matter. The Martians with the green, with the antennas would work wonderful, but the little tiny microscopic organisms, if something is found either current or past, that changes everything. I just can't imagine any bigger news that we could ever imagine than the headlines that say, life is discovered on Mars, on Europa, or wherever we think, or wherever we can find it. That's the big news of the day, and I think that will change everything. Perseverance. So NASA's newest Mars rover is scheduled to launch in July 17th this year. Only, May, June, July, two and a half months from now, roughly, from Cape Canaveral, Florida. Originally called Mars 2020, has been renamed. It was renamed early last month by a student here in the United States, Perseverance. It's similar to the Mars Curiosity rover, but it has a lot more new fancy gadgets, better cameras, and one of the major missions or goals of this particular Mars rover is to collect samples of Martian soil, cache them, contain them in containers, and then on a future mission, a mission will go and pick up those containers and return them to Earth so we can do extensive testing on the soil from Mars. So that's going to be pretty exciting. One of the other very exciting things about Perseverance is that there's going to be a helicopter. There's going to be a helicopter that's going to be aboard. And the helicopter, this is a picture, this is an image of the graphic of the helicopter that's going to be attached. It's going to be the first time that a helicopter has ever been attached to any spacefaring craft. And wouldn't you know, it just received its name just a few hours ago. Okay, just a few hours ago, Jim Bridenstine, the current NASA administrator, released the name Ingenuity, and that's the name of the helicopter. So if you happen to be in the area, look towards the east in Florida on July 17th, and hopefully you will be able to see a Delta V rocket blasting off from Cape Canaveral with Perseverance and Ingenuity. It's scheduled to land on Mars February 18th, 2021. Okay, so it generally takes 6 to 9 months to get to Mars, again, based on where Mars is in relationship to Earth. And so something definitely to take a look at and get excited about. All right, another topic I'd like to talk about, another big thing that's happening at NASA, NASA's Commercial Crew Program. Very exciting. So when the Space Shuttle retired, the Space Shuttle program ended back in 2011, NASA had an issue, a problem on its hands. And what was the problem? The problem was there was no way for us to get our American astronauts from America to the International Space Station. And so NASA contracted with Russia. And so since 2011, NASA has been paying Russia to ferry the American astronauts back and forth to the International Space Station. However, NASA signed 2 contracts with two private American companies, SpaceX and Boeing, to develop and to start ferrying our astronauts back and forth to the International Space Station. So on the left-hand side, we have a Falcon 9 rocket lifting off from Launch Complex 39A from the Kennedy Space Center with a work facility for SpaceX. And this, on the left-hand side of this picture, this is the Crew Dragon. This is where the astronauts will actually ride, and this will be here on top of the rocket, and they launch up to the International Space Station. So they've been doing a lot of testing, that is SpaceX and NASA, and so the good news is that NASA and SpaceX have a launch date, and the launch date is May 27th, 2020. Okay, that's coming up in just weeks. In just weeks, we will have two American astronauts, Ben Behnken and Doug Hurley. They will be inside of this Crew Dragon. That Crew Dragon will be on top of a Falcon 9 rocket, and it will be launched from Pad 39A at the Kennedy Space Center, going to the International Space Station. So very, very exciting to see that we are going to have American astronauts launched from American soil with private American companies, which, by the way, is going to be significantly cheaper for NASA than paying the Russians to ferry our astronauts back and forth. So we're going to be able to save a lot of money by having private commercial companies take over this responsibility. All right, on the right-hand side, you have Boeing. Boeing's capsule is called the Starliner. Unfortunately, Boeing has had some issues. Most recently, they did a test of their Boeing Starliner capsule, December 20th, 2019. And the intent was to launch the Starliner up to the International Space Station with no astronauts on board so that it could dock and then return, testing out the systems. Well, it never made it. It never made it to the International Space Station. And it was later found out that there were some software issues and problems. So it's going to apparently take quite a number of months for Boeing to correct those issues. It sounds like from the last time that I heard that they're going to be doing an additional non-human rated mission or launch to the International Space Station. And then once that goes well, then the next launch will have astronauts on board. So lots of neat things going on with NASA's Commercial Crew Program. All right. Next thing I'd like to talk about very quickly, CubeSats. I want to mention this because this is really exciting. CubeSats are very small satellites. And what's cool about them is they're so small, and I have a picture of this man here. I don't know if this is JPL or not. He is working next to this CubeSat here, and you can see that this is relatively small. The Hubble Space Telescope is the size of a bus. So you can see that this is relatively small, and what you can do, what NASA will do in private companies, is they can take these small CubeSats, and many are much smaller even than this. They will put them aboard launches with bigger satellites, and they kind of catch a free ride up into space because it is very expensive to launch things into space, and that's based on how much things weigh. So a quick little video here about CubeSats.
What is a CubeSat? CubeSats are very small spacecraft that orbit Earth. As you might guess, a CubeSat is shaped like a cube, about 4 inches wide, long, and deep. That's called 1 unit, or 1U, small enough to hold in your hand, and very light, around 3 pounds. And like building blocks, units can be combined to make bigger CubeSats by stacking them into 2, 3, or even 6 units. Once in space, CubeSats can open up all kinds of tools: solar panels for power, communications antennas, telescopes, and more. CubeSats are great because they let schools, universities, and other teams launch their very own missions, and who knows what they'll discover. CubeSats are also made from standard, low-cost parts that are easy to get and tested for launch safety. Some NASA launches carry spacecraft that don't take up all the space on their rockets, which leaves plenty of room for tiny CubeSats. Build a CubeSat, catch a rocket ride, and you become a space explorer.
All right. So that's just a little bit about CubeSats. Very exciting. New technology. A little humor. One day on Mercury lasts about 1,400 hours. Much the same as a Monday on Earth. Mondays do seem to last a long time, don't they? All right, so we're going to start wrapping this up. I see I'm only 2 minutes away from the top of the hour. I hope that you don't have to leave me. As promised earlier, I'm going to end up going over the hour, but there's just simply too much cool stuff to talk about. So if you need to leave me, I totally understand. You can always come back at your own time and watch this archived video on my YouTube channel at your own time. But if you do have time, please stick with me. I see some pictures in the chat, and I think what I'm going to do is, since I'm almost done with my presentation, I'm going to answer those at the end, if that's okay. Two big projects coming up for NASA. The first one is the James Webb Space Telescope. This is a telescope that's been under construction and design for many, 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 many years. It's been delayed many, many, many years. This is now currently scheduled to be launched from Guyana in South America next year. The James Webb Space Telescope will operate at roughly about 1 million miles from Earth. Now, if you remember, the Hubble Space Telescope is roughly about 350 miles above the Earth. So that's not very far. This telescope will be sent 1 million miles from Earth. And one of the major reasons it's going to be sent to what's called the L2, or the Lagrange point 2, from Earth, is because it has to operate in very, very cool conditions. And the Earth actually gives off heat, all right, the reflection of the sun in our atmosphere going back into space. And so they need to get it in very cool conditions. And so what you're looking here at the bottom is, this is a sun shield. And this sun shield will need to open once it's 1 million miles from Earth to actually protect it from the sun, all right? And this James Webb Space Telescope uses infrared photography. And what's exciting about infrared photography versus just typical visual photography? Well, infrared photography will allow scientists to see into the clouds of dust and gas that are in the sky. And when we can't see behind that cloud of dust and gas, we can't see, for example, stars forming and being born. And so this will allow us, in essence, to look through that cloud of dust and gas. So it's pretty exciting. Now I'm going to attempt to show you this video. It's a really cool, very short video, but every time I try to play this, I have problems. It just has problems loading. But if you kind of bear with me, it takes a little bit to kind of get moving. So hopefully it will get moving and we can take a look at this. So it's a thinking. It's a thinking.
The James.
And it stops. And I'll give it some time here to try to play. And if it won't play, I'll just let you watch it on your own. So let's just give it a minute.
The Webb Space Telescope is the next premier space observatory. It will extend the...
And it wants to stop again, but it will get going. Every time I go to this website, it does this. So it's not my internet connection, it's not my computer. It has something to do with where this video is hosted.
Discoveries of the Hubble Space Telescope. And observe the birthplaces of planets, stars, and galaxies. It is named.
And we're going to stop again. Or give it one more try and then I'm going to give it up. You can always do a search on Google.
After James Webb, NASA's second administrator and champion of many NASA science missions. At 3 stories high and the size of a tennis court, this will be the largest.
All right. So actually what I will do is I will put the link for this video in the comment section. And then when you come back, if you want to come back to my YouTube channel, you can always come back and see, get the link for yourself. Just simply come back to this archived video and look in the comments section, and then you can see the link for it. All right, so that's a little bit about James Webb. The second and last thing I'd like to talk about is perhaps the biggest project that NASA is currently working on, and that is what's called the Space Launch System, or the Artemis program, our return to the moon. And so on the left-hand side, you have an image of the rocket that will be used. We are currently calling it the Space Launch System. You can see that you have the main rocket, the fuel tanks here. You have solid rocket boosters on each side. These come from the Space Shuttle program. Right up here, this is where the astronauts will go in what's called the Orion capsule. I'll be showing that to you in a moment. Right here, this is the official logo for the Artemis program. Keep in mind that the first moon program was called Apollo in Greek mythology, and Artemis is the twin sister of Apollo. All right, so these names come from Greek mythology. Here's some information about the rocket. The SLS, or the Space Launch System, is a heavy lift, deep space hardware rocket. What does that mean? It's really, really big, and it can go really, really far. Not only will this rocket be used to take us back to the moon, this is the rocket that will be taking us onto Mars in hopefully the 2030s. It's evolvable. Okay, what does that mean? That means that it could either be set up in different rocket configurations with astronauts on board, or different configurations with payloads on board, for example, satellites. All right. Artemis 1, originally called EMS-1, I'll be talking about that in a moment, is scheduled for late next year, I believe November. I'll show you a plan about that in a moment. Artemis 2, scheduled for 2022 or 2023. All right, I'll show you a plan of that in just one moment. Artemis 3 is scheduled for 2024. It is the return of humans landing on the moon. The first woman astronaut, which is awesome. And we might even throw a couple guys in there, who knows. Here's the Orion capsule. This is being built by Boeing. The astronauts will be inside the Orion capsule. When it returns to Earth, it will be going at about 24,500 miles per hour. So it's going to be going significantly faster entering Earth's atmosphere than the shuttle did, returning at 17,500 miles per hour. The Orion capsule can accommodate up to 5 astronauts, though NASA has decided that they would probably work with a maximum of 4. Short little video here for you about the Orion capsule.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
Very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production,
And more in testing?
this system is capable of being the catalyst for deep space missions. We need a capsule that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources,
We're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable, that can land anywhere on the lunar surface. The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits
It will balance between the Earth and Moon's gravity.
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water, and we separate an oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
To prepare us and propel us to Mars and beyond.
This is what we are building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and on to Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going. We're going.
Pretty cool video. All right. I mentioned this earlier, Exploration Mission 1, now called Artemis 1. There's a whole lot of stuff going on here. But basically, this is supposed to be the first full test of the Orion and SLS program. It's going to be launched from Kennedy Space Center in Florida. It's going to travel around the moon. The mission duration is somewhere between 26 and 42 days. There will not be any astronauts on board, okay? EMS-2, now known as Artemis 2, launching again from Kennedy Space Center in Florida. It will have astronauts on board. There will be 4 astronauts on board. They will travel around the moon and return to Earth. The mission duration is currently scheduled for 10 days. They will not land on the moon. It will be Exploration Mission 3, or Artemis 3, hopefully in 2024, when we land human beings once again on the surface of the moon. Okay? As we wrap things up, please don't leave me because actually I might go ahead and mention this to you now. I know I have a lot of people attending from a lot of different areas, and if you would feel comfortable doing so, I would highly appreciate this. Would you feel comfortable please telling me what state you are from, city, state, or just simply what state you're from, and how you heard about this event? If you could just put that in the chat box for me, I would highly appreciate it if you feel comfortable doing so. If you don't, that's not a problem. I am somewhatly discouraged about talking about the budget, but I think that this is so important. NASA gets blank percent of the total U.S. federal budget. I'll give you a second to think about this. Your choices are A, less than 1%, B, 7%, C, 13%, D, greater than 20%. And the correct answer is A. NASA only gets about half of 1%. In money, that would be 1/2 of 1 penny. But when you think about all the incredible things that NASA does, I personally think that's a good use of our federal tax money. The images that I showed earlier are images that I've taken with my telescope, but you don't have to have a telescope. You don't even have to have a camera to take free pictures of deep sky objects if you'd like to. And all you have to do is type in Observing with NASA into Google, and you will come to this website. And what you can do is you can go through a variety of objects, deep sky objects, and pick one and ask this particular telescope to take a picture of it for you. And once that picture is taken, you will receive an email alerting you that the picture that you wanted taken was indeed taken, and here it is and how you access it. So you don't even have to leave the inside of your home, but you can also be taking pictures of deep sky objects. So again, you want to type in observing with NASA, and it will take you to that website. Two other pictures that I've taken with the assistance of my friend Leonard when it comes to deep sky objects. On the left-hand side, we have M51, the Whirlpool Galaxy, at about 23 million light years from Earth. And if you look down here, I accidentally picked up another galaxy, IC 4263, at about 125 million light years from Earth. And on the right side, we have M101, the Pinwheel Galaxy, at about 21 million light years from Earth. All right, I got some resources for you. You can always go to my faculty website, my Valencia College faculty website. I have lots and lots of pictures. One of my hobbies is traveling. I've had the opportunity to travel to all 50 U.S. states. I've traveled to all 7 continents, including Antarctica. So feel free to go to my faculty website if you'd like and check out some of those pictures. I also have pictures from Kennedy Space Center, Johnson Space Center, JPL, pictures with astronauts and all kinds of people, so check that out. NASA.gov is an awesome website to check out. Everything I've talked about here, you can find somewhere on the NASA website, so nasa.gov.com. And NASA Eyes. I mentioned this to you earlier, and if I can exit out of this for a second, I'm going to see if I can pull this up. Absolutely incredible NASA Eyes software. You go to NASA Eyes, look it up on Google, and let's see if I can demonstrate NASA Eyes quickly. There are 3 types. Eyes on exoplanets. An exoplanet is simply a planet that's orbiting another star, okay? Not our own star, the sun. Eyes on the solar system, so you can see everything that's happening in our solar system, and eyes on the Earth. And so I'm going to see if I can open up Eyes on the solar system. I can't recommend this enough. This is really, really an incredible program that NASA's put together at JPL. You can see the distances of satellites like Void in Time. It's incredible.
Welcome to Eyes on the Solar System, where you can explore your planetary neighborhood.
Okay, so you can zoom in, you can turn it, you can twist it, you can look at the Earth, you can look at different planets. I don't want to take much time, more time, but I highly recommend that you go and check this out. It's a really neat program.
Exploring them.
Okay, so I'm going to close that out, and I'm going to go back to my PowerPoint here. All right. Questions and answers. So, all right, I'm going to go in the box here, and I'm going to try to answer all the questions that you came up for me. Let's see here. Hi to everyone. Oh, so excited. You have a son that works at SpaceX. I want to go. I want tickets. Let's see here. What telescope do you have? I will tell you. Scientific Explorer. I should know that, but I forgot the name of it. So there you go. Yes, definitely watch the movie, Apollo 13, a great movie. How does NASA communicate with Voyager? Does it use radio waves? Yes, it uses radio waves, and it uses the Deep Space Network, I was talking about earlier. They have a large radio telescope in Pasadena, California. They have one near Madrid, Spain. They have one near Canberra, Australia. And so they're positioned around the planet so that regardless of how the Earth is rotating, there's always line of sight so that those radio waves can go be sent back and forth to all the spacecrafts on Mars and out in space and so on and so forth. So yes, they do use radio waves. CubeSats are cool. Let's see. Any questions? Anything? Am I missing any questions? I'm hoping I haven't overlooked any questions. If I overlooked one, can you please put it back in the chat right now for me? As we're wrapping things up, and I'll look at that one more time. Somebody asked me about future presentations. So my next YouTube Live will be on Tuesday, May the 19th. Tuesday, May 19th, 7 to 8 p.m. Eastern Time. Okay, 7 to 8 p.m. Eastern Time. The next one is on Thursday, June the 25th, from 3 to 4 Eastern Time. And so what I'd like to do is I'd like to do more of these, and I'd like to know what type of topics you all might be interested in me talking about. So if you have a topic that you would like me to talk about, can you please put it in the chat? And I will certainly, if I have information about that, I'll put something together. But please don't forget to subscribe to my YouTube channel. What's my favorite planet? Earth. I hope that we do a better job of protecting the Earth, because it seems to me that we aren't. As I tell my sociology problems, of all of the social problems we have, in my opinion, our number one problem is that we humans we're hurting the planet, and we need to stop. We really need to stop this. So I hope we do a better job. How does NASA communicate with Voyager? Oh, you missed it, Kathy. So radio waves. We use radio waves to communicate with Voyager. All right. Well, I want to thank everyone so much for joining me today. I have so much enthusiasm for this. I hope that you saw that. I don't have all the answers. But I have all the enthusiasm that someone might want to have for the space program. So please subscribe and keep in touch with me and let me know what other programs you'd like me to do in the future. So thank you so much for attending. Have a great afternoon. You can always come back and see this. It will be archived on my YouTube channel perhaps tomorrow. So thanks everyone. Thanks so much for coming.